Here I'm going to talk about fit distribution. If you're on first name terms with Hilltop, you might know this one as Fred. Fit distribution can be used to estimate the probability of a flood exceeding a particular flow or the likelihood of drought conditions. The process reads the data according to the sample rules and fits a frequency distribution curve to the result. Right, let's see how we make this happen. We go to Event, Fit Distribution. I want to look at flow at the Alphabet River and use all data. I want to look at low flows, so I need to use a retrieval interval to avoid any noise interfering with my results. I want Event to read the data across the whole year and produce one sample per year, so that's all correct. And I don't want a linear transformation. When I ran the L moments process on this data, it suggested a Gumbel distribution, so I'll select that. Here you can enter a value for uncertainty. Some data can reasonably have up to 20% systematic error, and for this data, it's about 10%. If you click here, Event will take the natural log of the data before fitting the data to the distribution. Then you can have log normal and log Pearson distributions and so on. If the sample values are 0 or less, it will cause errors, and you can enter a value to be subtracted from the data before the log is taken. Turn is useful where your data skews in the opposite direction to the inherent skew of the distribution. It'll flip the distribution around to suit and give a better fit. From data uses the entire range, but you can use these fields to limit the range of data for inclusion in the distribution. Now, the process uses the sample rules to read the data, ranks them in order, and then computes the probability associated with each sample by using a plotting position formula. The value of alpha controls the plotting position calculation, and for a Gumbel distribution, an alpha value of 0.44 is the way to go. Okay, here's my graph. It looks like it's a pretty good fit. These lighter lines here, either side of the trace, represent my 10% uncertainty. I just want to go back and go to the Graph tab. I can actually graph this on a Gumbel scale. This way the distribution will be a straight line and therefore make it easier to check for a good fit. You can have the horizontal axis labels displayed as percentages and set the range of the horizontal and vertical scales. This is handy to give you some room on the graph to extrapolate the results. Okay. Those values sit reasonably well on the line, so that adds credence to the assumption that our data does fit a Gumbel distribution. Let's have a look at the table Event has produced. As always, Hilltop shows our site, measurement and time range. It lists the L moments here. This table lists the values that have been selected according to the sample rules, and these letters identify each point on the graph. The annual probabilities have been computed according to the distribution we specified. The return period is the reciprocal of the annual probability. Common return periods are listed as well. The output states that annually there is a 5% chance of flow being less than around 10.5 cubic meters per second. Let's have a look at a flood analysis now. I'm going to use the same data, and this time I'll need to tick high flow. Event will compute exceedance probabilities on the largest value for each month. I'm not going to use a retrieval interval for my flood analysis, and this way I'll get the highest flow in each month. Using an interval is useful for evening out any noise, however, and around 3 hours is a good value for a flood analysis. The historical floods function is for where you have data on floods that occurred before a recorder was taking regular measurements at a site, and I talked about this in detail in the video on L moments. Let's talk a bit more about defining the season. Say we want to look at winters, so you could start the season in July and finish in September. If we take one sample per month, this could be problematic because storms may occur over 2 months, say, but be part of the same meteorological event. With the season set like this, the storm will be sampled twice, potentially biasing the results. A partition of 3 months would give a winter-to-winter comparison. Now we've defined the winter season, but say flooding most likely occurs in August to October in these parts. I can use Y on Z to avoid skewing the results. So I'm selecting for data 2 months inside the flood season, being August and September, and October lies outside my winter season. So I can enter a ratio where Y is the overlap period and Z is the length of the flood season. So that'll make it 2/3 or 0.66, so I pop that in here. Right, in this case, however, I want to analyze the entire year and select one sample per year, so I'll change these values back. Okay, and now for the distribution. I ran L moments earlier and it recommended a Gumbel distribution, and I've got the correct alpha value here of 0.44. For a normal distribution, use an alpha value of 0.375. If you don't know about the center clipboard function by now, you need to stop, go back and watch more of these tutorials. The Gumbel distribution does look like a pretty good fit. Let's have a look at the table. You can see here we've got a 50-year return period of 1145 cumex.